Hey, how's it going, everybody? In this video, we're going to go over Git command line basics. We're going to talk a little bit about what Git is, and then we're going to walk through how to get Git installed, and then the basic commands for working with local and remote repositories. I'm going to use a couple of images in this walkthrough, and these images were taken from the Pro Git book written by these two authors here, and it is licensed under the Creative Commons. If you want to read the book, which is a great resource, you can go to the Git website, click on the documentation, and the book is listed there. So this video is going to be useful for three different types of people. First of all, somebody who has never used version control before. This is a great place to start because Git is the most widely used version control system out there. Second, for people who have used version control but not Git. So if you're coming from a version control system like SVN, then it's going to be great to learn about Git also. And third, this will be useful for people who have used Git but have mainly used the GUI visual tools. So the GUI tools are really useful, but it's better to learn these command line tools from the very beginning because the GUIs can only do so much, and you'll eventually run into a situation where you get stuck, and the underlying knowledge of the command line would be extremely useful. So with all that said, let's go ahead and get started. So first of all, Git is a distributed version control system. So if you're coming from a version control system like SVN, which is a central version control system, then what is the difference between central and distributed version control? Well, a central version control system is located in one place. So people can check out from this central location and make their changes and then check everything back in. But this can be problematic if you can't get access to that central server or that central repository. So for example, if that server's offline or you're working somewhere that doesn't have a network connection, then you'll only be able to see the files that you've checked out from that repository and no additional information about that central remote repository. Also, if something happens to that central repository or it somehow gets corrupted, then you've got to hope that there's a backup of that code somewhere. Now, on the other hand, a distributed version control system like Git, in this situation, everybody has a local repository. So you can have the option to have that central remote repository, which we'll look at here in a little bit. But your local repository has all of the information that your remote repository has based on the last time that you sync those two together. So the good thing about this is that if you don't have access to that remote repository, then you can still view every single change that's been made to that repository since it was created. So in a way, it's almost like every developer has an entire backup of the repository. So in the worst case scenario of something happening to the remote repository, every developer has a copy of that same repository on their machine. So that's why it's called a distributed version control system. So now let's go ahead and get started with Git. Now I'm not going to go into too much detail about the installation here. If you go to the website, which is git-scm.com, and then you go to the downloads tab here, then you can find the download for any operating system that you're working with, and the installation is pretty self-explanatory. So after we get Git installed, there is a first time setup that we have to go through. So first of all, after you get Git installed, then you can check the version to make sure that it installed correctly. So if you run this command here, git --version, so I'm going to open up my terminal window here. Now, if I run git --version and it pops up with some version here it says Git version 2.3.2, then that means that Git is successfully installed. Now once you have Git successfully installed, now we need to set up some global configuration variables. Now these variables are important because if you're working with other developers, then they need to know who is checking the code in and out and making changes and things like that. So this is a way to add your name to all of your check-ins and code changes. So this is the syntax here to add these variables in here. So if I go back to my terminal, I can type git config --global user.name, and then in quotes I can type in my name here. So I'll type in Corey Schaefer, hit enter, and now we can do the same thing for email. So I'll type in user.email, and then here I'll type in my email address at gmail.com, hit enter. And now after we've put in those values, then to check those values, we can do git config -- list, and this will list all of our configuration values here. Now I'm going to have a little bit more than you do. You'll probably only have a few values here, but I've customized my Git a little bit over time, so you can see all the values that I have listed here. But the important ones to look for are to make sure that we have our user.name set and our user.email set. So once you have those values working, then you are good to move on. Now git config was the first Git verb that we actually used. It was the first action that we used. Now if you ever need help with any of these actions, then you can use this syntax, either git help in the verb or git verb -- help. And what I mean by that is using config as an example. So say I want to see what you can do with the config action. So I can do git help config and hit enter, and it'll take me to the manual page, and you can read all about it here. Or the other syntax that you can do is git config -- help and read through there. And you can do this with any git action. So you git add -- help does the same thing. It takes you to the manual page for the add action. So that's extremely useful once you start doing more intermediate and advanced things with Git. It's useful to look at those manuals and see exactly what you can do with them. Now there are two common scenarios for people to begin using Git. So the first scenario is that you have an existing project on your local machine that you want to start tracking using Git. And the second scenario is whenever there's an existing project remotely that you want to start developing on. So first let's take a look at that first example where you have a local code base that you want to start tracking using Git. So in order to do this, it's just as easy as running the git init command from within the directory in your terminal. So for example, let me pull up my terminal here. Now the code that I want to start tracking, if I do an ls within this directory, the code that I want to start tracking is within this local repo directory. So if I cd to local repo, and then I do an ls-la in here, which will list all of the files in the directory, you can see that there is a .project file here, and there's a calc.py file here. So to begin tracking this code with Git, it's just as easy as running git init. And if I hit enter, you can see that it initialized an empty Git repository. And now, if I do an ls-la, then you can see that it placed this .git file here. Now this .git, it's actually a directory. This .git directory contains everything that's related to our repository. So if we ever want to stop tracking our project with Git, then all we have to do is remove this Git directory just like we would any other directory. And if I do an ls-la, it's gone, and we're no longer tracking this project with Git. But we don't want to do that. We want to track this project. So let's do this again. Now you can see it put that Git directory back there. And now we are using Git within this directory. So now we're using Git in our directory, but we haven't actually committed anything yet. So before we commit anything, let's first run this git status here. So if I pull up my terminal and I run git status, you can see here that we have two untracked files, .project and calc.py. Now this .project file is just a file that I created as an example of a file that we don't want in our repository for other people to see. So there's a lot of files that contain personal preferences specific to our machine or our operating system that aren't actually part of the code that we want tracked. So for example, say that I had my personal preferences within this .project file. I wouldn't want to add those to the repository, and whenever other people check those out, they would be getting my preferences, and we don't want that. So what we want to do is ignore these files, and to ignore files, you just have to create a .gitignore file. So I'm going to do a touch on a .gitignore file, which will create that gitignore file. And now let me go ahead and open this up in my text editor. Okay, so the gitignore file is just a simple text file where we can add files that we want Git to ignore. And we can also use wildcards. So for example here in this slide, I have this star.pyc, which will ignore all files with a pyc extension. So that's a Python example, but that's not important. I'm just showing the concept here. So let's go ahead and add all these files here to our gitignore file, and I'll paste that in and save that. And now let me go back to my terminal. Now that we've added those to the gitignore file and saved it, now let's rerun git status. And now you can see here that the .project file is no longer coming up in our list of untracked files. It's only the .gitignore file and the calc.py file. And we want to commit the gitignore file because we want the repository to know to always ignore those files. Okay, now let's take a step back here and try to picture exactly where we are right now. Now with Git, there are three states that we need to know about. There's the working directory, the staging area, and the committed files. And right now, we're currently in our working directory. So untracked and modified files will be in our working directory, and it will list those when we ran git status. So you can see here, if I open up my terminal, then these are the files in our working directory here. Now the staging area is where we organize what we want to be committed to our repository. Now the reason for the staging area is so that we can pick and choose what we want committed. So if we've done a lot of work spanning multiple files and we want to make multiple commits from those changes, then you can stage individual files and commit those in small chunks at once. So that's going to allow us to be more detailed with our commits. So for example, you don't want to make a commit where you add a message that just says like, I made a lot of changes to the code. You want commits that are very detailed as to what changes were made. So now that we know about that staging area, let's go ahead and add files to the staging area. So if we want to add all the files that are currently untracked or that we've made changes to the staging area, then we could run git add -A, or we could add these individually. So for example here, if I did a git add .gitignore, then if I do a git status, then that's going to show us, okay, so here we have calc.py, which is currently untracked, and then you can see that our gitignore file is in our staging area because we ran git add.gitignore. And like I said in the slide, if we want to add everything to the staging area, then we can just do git add -A and hit enter. And now if I run git status, then you can see that all of our files are now in the staging area. So if we were to run git commit right now, then it would commit these changes to our repository. Now if you ever want to remove files from the staging area, then you can use the git reset command. So if I did git reset calc.py and then did a git status, you can see that the gitignore file is still in our changes to be committed, which is in the staging area, and our calc.py file is in the untracked files. If you want to remove everything from the staging area, then you can run git reset without any other options and it will remove everything. So if I type git status now, then you can see that all these files are moved back to our working directory as untracked files. Okay, but we actually want to make a commit now. So let's go through this process again. What we want to do is we want to run git add -A to add everything to the staging area. And now if I run a git status, you can see that all of these changes will be committed. And in order to get these, in order to commit these files, we run git commit and then -m, which will put a message. Now the messages are important. You want to be detailed as to the changes that you made to the code. But this is our first commit here, so we're just going to put something like initial commit. So if I hit enter there, you can see that it added the two files to the repository. Now if I run a git status, you can see that it says that the working directory is clean. That's because we've committed those files and now we don't have any modified or untracked files. Those are being tracked now and we haven't modified them since we committed them. Now another useful command here is the log command. So if we run git log, then we can see the commit that we just made. So this gives us the hash number of that commit. Now all those hashes will be unique, and then you can see that our author who made the commit and then the message for that commit also. So now for this example, we are successfully tracking our local project and we have made changes and committed those changes to the repository. So now let's talk about the situation that we mentioned earlier where we want to track an existing remote project with Git. Now this is likely how most of you will be using Git if you're going to be using it in the workplace. So for example, say that your company has a remote repository and you want to clone that remote repository and begin developing on it. Now the syntax for this is git clone, and then the URL, and then where you want to clone that repository. So in the example that I'm going to use this remote repo here, which is actually just a directory on my local machine. Now usually this is going to be a URL. So for example, if this was coming from GitHub or something like that, then it may look something more like this. So you do git clone and then the URL of the remote repository and then where you want to clone that repository. So in this case, the dot just means in the current directory. But like I said, in this example, I'm going to be using this directory here, which is on my local machine, but it's going to behave exactly like a remote repository would. So let me open up my terminal and let me go back to this Git Basics directory. Now if I run an ls here, then I have this directory called clone repo. I'm going to cd into that. Now if I do an ls-la here, then you can see that this is completely empty. These are just relative paths here. So now I want to clone a remote repository here. So I want to do a git clone and then the URL of the repository, and then this dot means that I want to clone all the files from that repository into this current directory. So if I hit enter, you can see that it cloned into the current directory. Now if I do an ls-la, then you can see now I have files here. Now I set up this sample remote repository to be very similar to the example that we just used in the local directory. So now that we've cloned that remote repository, now let's see how we can view information about that remote repository. So in order to do that, we can use a couple of commands. One of these commands is git remote-v and another is git branch-a. So if I was to do git remote-v, then you can see it lists the information to the repository here. So this is just the location on my local machine of where this repository is. And also if I was to do git branch-a, then it will list all of the branches in our repository, not only locally, but remotely as well. Now we haven't gone over branches yet, but we will do that here shortly. Now let's make a couple of changes to the code base, and we can take a look at how to commit those files and how to push them to the remote repository. So over here, I'm going to go into this clone repo and open up this calc.py file. And now I'm just going to make a simple change here. I'm just going to change this multiply function to return what we want it to return. So I'll do return x times y, and I'll save that. So now we've made a change to our code. So now that we've made a change to our code, how are we going to push these changes to the remote repository? So first, we need to commit these changes locally, just like we did before. So if I open up the terminal here, then the first thing I can do is git diff, and git diff is going to show me the changes that I have made to the code. So you can see here that it has this minus sign with the past, that's what I removed, and then the plus sign here, return x times y, that's what I added in. So those are the changes that I made to the code. Now if I run git status, we've seen this before, then you can see that in our working directory we have this modified.calc.py file. And now if you remember, we want to add those to the staging directory so that they can be committed. So we'll do a git add -A to add all the changes. Now if I run git status again, then we can see that those are ready to be committed. And now we can do git commit -m, and then for a message here we can just do multiply function. Okay, so now we have committed these files locally, and now we want to push these changes to the remote repository so that other people have access to those. Now whenever you're ready to commit those changes and push them to the remote repository, there are two things that you want to do, a git pull and a git push. Now people a lot of the times forget the git pull, but you have to remember that we're now working on a project that could potentially have multiple developers, and people have been pushing code to that remote repository while we've been working on our own features. So what the git pull does is it will pull any changes that have been made since the last time that we pulled from that repository. And as you can see, after we ran that pull, it said that we were already up to date because there have been no changes to that remote repository since the last time that we pulled from it. And now we're ready to push. And we will do a git push. And this origin here is just the name of our remote repository, and then the master is the branch that we want to push to. So if we run that, then we have successfully pushed those changes that we just made to the master branch of that remote repository. So now that we've worked a little bit with local and remote repositories, now let's go ahead and take a look at a common workflow that a lot of developers use when working with Git. So I said before that we were going to take a deeper look into branching. So far we've been working directly on our master branch, but this isn't really how you should be using Git from day to day. So let's say that, for example, now instead of that multiply function, we want to work on our divide function. So a common workflow that you're going to use to do this is to create a branch for your desired feature and then begin working off of that branch. So the syntax for creating a branch is git branch and then the name of the branch, which we'll just call calc divide. So I'm just going to copy that. Now let's open up our terminal, and now let's create that branch. So git branch calc divide. And now if I run git branch without the branch name, then it's going to list all of my local branches. You can see that I have master here, which has the asterisk beside it, and that means that that's the branch that I'm currently working on. If I want to start working on the calc divide branch, then I have to check that branch out, and that's using this syntax here, git checkout, and then the name of the branch. So I'm going to do git checkout calc divide. Now if I rerun that git branch, you can see that I am working on the calc divide branch. So now let's start working on the changes that we want to make on this branch. So the changes I want to make here, I want to work on this divide function. So I want to return x divided by y, and I'll save those changes. And now that I've made those changes, now let's just commit this just like we have been doing. So if I do a git status, you can see that our calc.py file has been modified. I want to add those changes to our staging area using the git add command. Then I want to do a git commit with a message of, we'll just call this divide function. And now we have successfully committed this change to our local calc divide branch. Now this had no effect on our local master branch, and it's had no effect on our remote repository. So now let's say that we want to push this branch to our remote repository. So this is the syntax for doing that here, this git push -u origin, which is the name of our remote repository, and then the branch that we want to push to. Now I'm not going to go too far into what that -u does since it's a basic Git video, but basically the U option just tells Git that we want to associate our local calc divide branch with the remote calc divide branch, and then in the future, instead of doing this git push -u origin calc divide stuff like that, we can just do git push and git pull like this, and it will know that those two branches are associated to each other. But we're not going to go too far into that right now. So if I pull up the terminal here and I do this command git push -u origin calc divide, hit enter, now we have pushed that calc divide branch to the remote repository. So now if you remember earlier we did this git branch -a command, and if we run this again, this command was to see all of our branches. So if we run this, then you can see that we can see our two local branches here, calc divide, which has the asterisk, which means we're currently working on that branch. And then we can see that in our remote repository, we have a calc divide branch and the master branch. Now there's a lot of reasons for why you would want to push your branch up to the remote repository. In a lot of companies, that's where they run their unit tests and things like that to make sure that all the code runs well before it's merged with master. But let's say that all of those unit tests and everything ran really well, and now we're ready to merge that branch with master. Now the way we want to do this is we want to check out our local master branch. So we'll do git checkout master, and you can see here that we switched to our master branch. Now we want to pull all the changes down. Remember, before we commit anything to master, we always want to pull down the changes in case any changes were made while we were working on our feature. You can see here that it says that we're already up to date because nobody else has made changes to that remote branch since we've been working on the calc divide branch. And now we can do this option on get branch here, which is -- merged, and what that's going to tell us is the branches that we've merged in so far. And you can see here that if I run that, calc divide doesn't pop up here because it hasn't been merged yet. So in order to merge that branch with master, you do a git merge and then the name of the branch. So I want to merge calc divide with master, so I'm in the master branch, and I do a git merge calc divide, and it will merge those changes into master. Now that I've merged those changes into the master branch, then I can push these changes to our remote master branch by doing a git push origin master, just like we did before. And then now those changes have been pushed to the master branch on the remote repository. So now that we have finished merging those changes from calc divide, now that feature is done and we're ready to delete that branch. So that same command that I ran earlier, just to double check that everything was successfully merged, if we rerun git branch -- merged here, now you can see that calc divide shows up here. So that means that we have already merged in all the changes in that branch into master. So now we're ready to delete that branch since it's no longer necessary. So we can do git branch and then -d, which will delete it, and then calc divide, which is the name of our branch. So now that has been deleted locally. But remember that we also pushed that branch to the remote repository. So that command that we did earlier, git branch -a, if we run that again, then you can see that we deleted our local branch and all we have is master, but we still have this calc divide branch on our remote repository. So to delete a branch from the remote repository, then it's this syntax here. We can do a git push origin, which is the name of our remote repository, -- delete, and then the branch. So if we run that, and then we rerun git branch -a, you can see that all we have is our local master branch and our remote master branch. Okay, and I know that that was a lot to take in, especially if you're new to something like Git, but it's really not that bad once you get the hang of it and this becomes part of your daily routine. Now, really quick, I'm going to run through a faster example here because I know that that seemed like a very long process, but if I'm not talking through step by step, then you'll see how fast it is to actually make these changes with this workflow. So for example, run the master branch here and say I wanted to work on the subtract function. So I can do git branch subtract and then git checkout subtract. So now I'm working on the subtract branch. I can come in here, make the changes. We want to return x minus y, save that, do a git status over here. We've modified that. We want to add that to our staging directory. Now we want to commit those changes. And you want the commit messages to be more detailed than that, but this is just an example. And then we can do a git push u origin subtract. So now we've pushed that branch to our remote repository. And let's say that all those tests ran well, so now we're ready to merge this with master. We can check out our master branch, and now we can do a git pull because we want to pull in all the changes that have been made. So now we pulled in all the changes. Now we can do a git merge of the subtract branch. This will merge subtract with master, and now we can push those changes. And then you can go through the process of deleting that branch just like we looked at earlier. But you can see how that process isn't actually as slow as it was with me going through and step-by-step explaining it along the way. So that was a broad overview of using the Git command line on local and remote repositories. I know that was a lot to take in for one video, but I really hope it was useful for you guys. If you do have any questions, just ask in the comment section below. Now there's a lot that we didn't get to in this video, and I'm going to make additional videos soon on other topics, like if you run into merge conflicts, if you need to undo your mistakes, some other common pitfalls, tagging versions in Git, and also advanced topics like your Git history, rebasing, cherry picking, and things like that. So be sure to subscribe to the channel to make sure that you catch those later videos. And again, I hope this video was useful for you all, and thank you for watching.